Hello everyone, my name is Mayur Gohil. Welcome to the video lecture series of Laplace transforms. In this video lecture, we are going to see inverse Laplace transforms. It's a new concept. For this video lecture of inverse Laplace transforms, you will need your formula list that you have been preparing every time. And you have been updating those formulas from the previous video lectures. If you are new to this video lecture, I have already shown one video regarding the formula list of Laplace transforms, in which we have seen various formulas of Laplace transforms of certain standard functions as well as certain results such as first shifting theorem, multiplication effect, and so on. I hope you keep it ready with you for your reference, because for this topic you would need to refer it again and again. Let us start with inverse Laplace transforms. Here in this topic, what we will be seeing is, we are aware that Laplace of f of t is equals to phi of s. Now it would imply that f of t is equal to L to the power minus 1 phi of s. Now this L to the power minus 1 is read as L inverse or Laplace inverse. Okay, so you read it as f of t is equals to L inverse of phi of s, or f of t is equals to Laplace inverse of phi of s. Like we already had seen that L operator is a linear operator, similarly L inverse is also a linear operator. Okay, so L inverse is a linear operator. So anytime any scalar, or there are two functions over which L inverse operator is operated, then you will have it getting distributed and pulling the scalar outside the function. Okay, now let us see an example to understand how to solve inverse Laplace transform problems. We have here a question, that is L inverse of 1 upon s plus a is to be found. Now we are going to refer our formula list. What we have to ask the question is, we have to find a function whose Laplace is 1 upon s plus a. If you refer the formula list, then you will see that there is one of the Laplace of a particular function is of the form 1 upon s plus a, or it is in a similar format. If you observe the corresponding function, it would be in the form of e to the power minus at. So the answer for this question is e to the power minus at. If this doesn't clear you, let us see one more example how to understand this. Consider Laplace inverse of 1 upon s to the power 5. Okay, now we are interested in finding this answer. How do we go about it? First, we ask this question, we need to find f of t such that Laplace of f of t is 1 upon s to the power 5. Okay. The next thing is required, that from our formula list we are aware that t to the Laplace of t to the power n is gamma n plus 1 upon s to the power n plus 1. So if we try to write Laplace of t to the power 4 equal to gamma phi upon s to the power phi. That is what we get. Then what we see ahead is t to the power 4 divided by gamma phi is equals to Laplace inverse of 1 upon s to the power phi. How do you obtain this? Because when we take this Laplace operator onto the right hand side, it becomes Laplace inverse. Now the gamma phi is a number, it's a scalar, thus it comes outside and you can shift it to the denominator of left hand side. So finally we obtain is L inverse of 1 upon s to the power phi is equals to t to the power 4 upon 4 factorial, which is gamma phi. Okay, let us see the next thing. Okay, now observe here, this is something one step ahead. We have to find Laplace inverse of s minus 3 over s minus 3 the whole square plus 2 square. If you observe this function properly, it is suiting to which format in the formula list, that is what you try to search. So if you observe, if you replace this s minus 3 by some quantity m, so it is m upon m square plus 2 square. So it is the format of cosine's Laplace. But s is shifted by s minus 3. Thus we will use first shifting theorem now. So how it will come to the picture? Since s is shifted by s minus 3, you have to have in shifting theorem it would be e to the power 3t. Okay, and what would remain is now the net effect. Net effect is s square, and here s is replaced, s minus 3 is replaced by s. So the net effect would be L inverse of s upon s square plus 2 square. And if you now observe, this is nothing but Laplace of cosine 2t. So finally the inverse of this would be e to the power 3t times cosine 2t. I hope you have followed it. Since this inverse Laplace is asking us to go into the reverse direction, it is sometimes trickier to see the reverse way, because every time we were having a habit of given the function, we were getting the answer in the terms of 1 upon s plus a or some other terms where the function was expressed as in terms of s. Now what we are given is, we are given the Laplace, we have to find the function. So it is sometimes tricky. It is tricky only in the initial stage. Once you settle up with what is happening, you refer the formula list, try to see it in a reverse direction, then you will be able to get the functions also. So I leave one small question for your practice. How you have to do it, I give you the hint. If you observe the denominator, try completing the square and try separating it up, separate the numerator, or you can also express in this form the way we did this first shifting theorem, and you can solve it easily. Okay, I now give one formula. If you have found any difficulty in this example too, see here, this formula L inverse of 1 upon s to the power n plus 1 is equals to t to the power n over gamma n plus 1. This formula is just giving you a guidelines, but it is obtained from the same formula. Okay, try to observe the formula and you can derive the Laplace inverse formula from the original formula itself. Okay, that's it. Thank you.